All right, so our next video for this week is just following the directions for how to multiply fractions. And multiplying fractions is one of the easier things to do in a fractions unit. And the way we start off with multiplying fractions is we always need to turn a mixed number into an improper fraction. But the problem is I don't know if we remember what an improper fraction is versus a mixed number. So I'm going to give you some examples. So here is a mixed number example. A mixed number always has a whole number, whereas an improper fraction has a heavy numerator on top. So the numerator is always bigger than the denominator. Now, in order for us to turn a mixed number, so here's an example of 3 2/5. In order for us to turn a mixed number into an improper fraction, we're going to use what we like to call the magic C. And in order to do the magic C, you're actually going to draw a C on your fraction. And you're going to multiply the denominator and then you add the numerator. So what that looks like is I'm going to start at the 5 because that's where my C starts. I'm going to do 5 times the whole number, which is 3, because the whole number would be, if I could rewrite it, I could rewrite it as 5/5, and I need 3 of them because there's 3 wholes, plus 2 extras that are left over, and then the denominator stays 5. 5 times 3 plus 2 becomes the numerator, so 5 times 3 is 15, plus 2 would be 17 over 5. So that is how you go about using the magic C. So let's do one more example. So we have 2 3/4. Magic C, multiply at the bottom, add at the top. Rewrite it. 4 times 2 plus 3. I'm just going around the C. 4 times 2 plus 3. All over, the denominator stays 4. 4 times 2 is 8, plus 3 would be 11 over 4 as an improper fraction. So go ahead, I'd love for you to pause, and I want you to do the 2 you try questions. So for this one, I do the magic C, multiply at the bottom, add at the top. So that would be 4 times 5 plus 1 all over 4. 4 times 5 is 20 plus 1 will be 21 over 4. And then for number 2, magic C, multiply at the bottom, add at the top. 6 times, let's write it out. 6 times 4 plus 3 all over 6. 6 times 4 is 24 plus 3 would be 27 over 6. So that is how you turn numbers into improper fractions. Now let's actually talk about those fraction multiplication steps. So the steps to solve a fraction problem. First thing you need to do, and we just did this on the previous page, is turn mixed numbers into improper fractions. Step 2, we're going to put the fractions side by side. Step 3, we're going to multiply the numerators together. Step 4 is multiply the denominators together. And then step 5 is to simplify. So let's look at our 2 examples that we have. And I apologize, I forgot to finish writing this example. And if we look at our 2 examples, our first one is 4 1/5 times 2/3. So step 1 says turn mixed numbers into improper fractions. So I'm going to turn this improper. If you need to write off to the side that little work that we were doing on the previous slide, you're welcome to. So I'm going to do multiply at the bottom, add at the top. So 5 times 4 plus 1 over 5. 5 times 4 is 20 plus 1 gives me 21 over 5. So this fraction is going to be 21 over 5 times, I'm just going to bring down 2/3 because I don't need to do anything with it. And then I'm going to multiply my numerators because they're already side by side, across the top, across the bottom. 21 times 2. I'm going to do some work over here. 21 times 2. 1 times 2 is 2. 2 times 2 is 4. So that becomes 42 over 15. Now I need to look at this. They're not even, so they can't be divided by 2. They're not end in 5 and 0. They're not 5 or 10. I can't do 11 because they're not doubles. I'm going to try 3. If you look on your multiplication chart, 15 will be on there. 42 may not be, but 42 does divide by 3. So I get 42 divided by 3 is going to be 14, and 15 divided by 3 would be 5. Now, you may leave improper. Can leave improper. We will not make you turn it back into a mixed number. If you do get answer choices with mixed numbers, you can turn your mixed numbers improper. All right, let's look at our next example. Now, our next example is a little bit different just because I have a whole number of 9. Anytime you have a whole number, you need to give it a denominator of 1 because it's a sad and lonely number, and the 1 needs a best friend. And then I also need to do a magic C to that one. So 9 over 1 is just going to stay 9 over 1 times magic C here, multiply at the bottom, add at the top. So this will be 4 times 1 plus 1 over 4. 4 times 1 is 4, plus 1 gives me 5 over 4. So this improper, or this mixed number is really an improper fraction of 5 over 4. Multiply my numerators, multiply my denominators. 45 times, or 9 times 5 is 45. 1 times 4 is 4. They're not both even. They don't end in 5 or 0. They're not doubles. 3 doesn't divide 4, and I don't know of any other factors, so that one is finished. All right, what I would like for you to do is I want you to try the 2 you try problems. And when you're ready, unpause the video and we'll check your work. So for the first one, you needed to turn this improper first, multiply on the bottom, add at the top. So that would be 7 times 2 plus 2 over 7. 14 plus 2 would be 16 over 7. So this is now 16 over 7 times 2/3. Multiply across the top, multiply across the bottom. 16 times 2, I don't know, so I'm going to do 16 times 2 off to the side. That'd be 12, 32. 7 times 3 is 21. They are not both even. They don't end in 5 or 0. They're not doubles. 3 doesn't divide 32, even though it divides 21. And I don't know of any other factors that would work, so I am done at 32 over 21. For number 2, you actually had to do the magic C to both of them because there were whole numbers for both fractions. So for the first one, it'd be 2 times 2 plus 1 over denominator 2. 2 times 2 is 4, plus 1 is 5 over 2. So this one's 5 over 2 times 4 times 1 plus 2 over 4. 4 times 1 is 4 plus 2 gives me 6 over 4. All right, multiply the numerators, multiply the denominators. 5 times 6 is 30. 2 times 4 is 8. Now, those are both even. So I'm going to divide by 2. 4 does not work if you try to simplify by 4. And I get 15 over 4. They're not both even again. They don't end in 5 or 0. They're not doubles. Evil 3 does not divide 4, so I am done. Now, I know some of you really, really hate simplifying fractions at the very end, especially when you're starting to multiply them. Like that 32 over 21, those are big numbers. We could even get some larger numbers as we start to do some multiplying with fractions. So I'm going to give you an optional method for simplification. If you don't understand the next method that I go over, that is okay, but I'm just giving it to you as an option. So we are going to discuss really quickly cross-simplifying. So why would you want to cross-simplify? It keeps the numbers smaller as you do the work. So you're going to make your numbers smaller before you actually multiply them. It actually is easier for your simplifying too because you're dealing with smaller numbers. And how do you do it? You're going to simplify your fractions diagonally before you even multiply them. So while we're doing this, I would love for you to pick up 2 colored pencils so that you can either circle or shade the numbers together. And I'm going to use my highlighter tool and my colored pencil. So I have this first example of 6/10 times 2 14ths. And what cross simplification said is simplify your fractions diagonally. So I'm going to use the color, well, I'll use red for right now. And I'm going to look at my fractions that are diagonal. So if I look at the number 2 and the number 10, is there something I can divide both 2 and 10 by? Well, they're both even, so I could divide 2 by 2 and I could divide 10 by 2. 2 divided by 2 would make the numerator of the new fraction. And let me rewrite this with my pencil. So I'm going to rewrite my fraction down here. 2 divided by 2 would give me 1. 10 divided by 2 would give me 5. So you can see that I simplified diagonally. I changed the numerator of the second fraction and I changed the denominator of the first fraction. Now I'm going to pick up my second colored pencil and I'm going to look diagonally the opposite direction. Is there something that could simplify both 6 and 14? Well, yes, they both can divide by 2. If I do 6 divided by 2, I get 3. And if I do 14 divided by 2, I get 7. So now I actually just simplified my fractions to make my multiplication much easier. And I actually won't even have to simplify at the end. 3 times 1 gives me 3. 5 times 7 gives me 35. And it is done because I did all the simplifying at the beginning of the problem instead of at the end. So cross-simplifying is just simplifying the problem before you actually do the work. Let's look at another example. So the next example has a whole number in it. Before you can do cross-simplifying, you have to turn that improper. So that would be 4 times 2 plus 1 over 4, would be 8 plus 1. So that gives me 9 over 4 as my improper, times 2 over 3. And then I'm going to set up my fraction that I'm going to fix down at the bottom. I'm going to go back to my blue colored pencil, or my red, I'll start there. Doesn't matter. 4 and 2. Do they have anything in common that I could simplify by? Well, I could divide those both by 2. 4 divided by 2 is 2, and that's in the denominator. 2 divided by 2 is 1, and that's in the numerator. Change colors. I'm going to look at the second diagonal, 9 and 3. Is there something that divides both 9 and 3? Well, yes, they both divide by 3. 9 divided by 3 would be 3, and that's the numerator. 3 divided by 3 is 1, and that's the denominator. Now I'm just going to multiply them. 3 times 1 is 3. 2 times 1 is 2. And it doesn't simplify. It's done. So I want you to attempt this. I know it's something new and it can be something tricky, but use your 2 colored pencils. Make sure for number 2 you turn it into an improper fraction first. Pause here, see if you can figure out how to do it so you can simplify first. So if I look at number 1, the first diagonal, they both divide by 5. So 5 divided by 5 gives me 1 in both the denominator and the numerator that are diagonal from each other. And then if I go the opposite direction with the 3 and the 6, 3 and 6 can both divide by 3. 3 divided by 3 is 1, 6 divided by 3 is 2. And then now I just have to multiply them together. 1 times 1 is 1, 1 times 2 is 2. Done. No simplifying required because I did all the work in the beginning. Now for this one, I do need to turn it improper. 3 times 1 plus 1 over 3, 4, or no, I'm sorry, that would be 3 plus 1 gives me 4 over 3. So this improper is 4 over 3 times a half. Now let's check to see if I can do any cross simplifying. If I look at 1 and 3, nothing simplifies there. So that doesn't help me. But I can look diagonal the opposite direction, 4 and 2, those both divide by 2. So 4 divided by 2 would be 2, and that's in the numerator. 2 divided by 2 would be 1, and that's in the denominator. I'm going to leave the other 2 alone, so that's 3 and that's 1, and just multiply. 2 times 1 is 2, 3 times 1 is 3. Done. Make sure you let your teacher know if you have any questions. Don't forget to finish all the other things that you need to for this week, including to post your notes and to do the exit ticket. Thank you so much.